Hey, this is Mr. Beckstrom. Today I wanted to take a look at section 3.2, and here we're looking at number 12, and we are trying to kind of do a visual type problem where we're looking at some function. We don't know how that function is defined mathematically. We're just given a visual representation, and we want to try to identify it with the graph of its derivative. So we don't actually know what the function of the derivative is, but we want to use some characteristics of the graph and the idea of the slope at different x values in order to, or the slope of the tangent line at different x values in order to kind of maybe use a process of elimination to kind of hone in on which of these red curves is the graph of our derivative function. All right, so let's take a look at this first one. So one good strategy here is to, with a curve like this, is to find anywhere where we're going to have a tangent line with a slope of 0. And a slope of 0 means that you have a tangent line that's horizontal. It's going straight from left to right, a horizontal line. And notice that you only have one point. That's at x equals 0 right here, where you're going to have a horizontal tangent line. So that means that x is equal to 0. Your tangent line slope is going to be equal to 0. So when we graph that, it's going to be 0, 0 for your derivative function. So that means we should have that point on our derivative function. So it has to touch the x-axis at 0, 0 on our derivative function. And so it looks like it does it there, it looks like it does it there, it does not do it there, and it does it here. So we can kind of eliminate C. The next thing I want to notice is that there's only one place on this graph with a horizontal tangent line, so it should only be touching the x-axis one time, because whenever it touches the x-axis, we're going to have a tangent line with a slope of 0. So since it only touches it, since there's only one place with a tangent line with a slope of 0, that means we should only have one place where it touches, where the derivative curve touches the x-axis. So now I can eliminate A. So let's see what else I can eliminate. I can also eliminate C now. All right, so now we're just looking between D and B. So what do we think? Do we think it's D, or do we think it is B? All right, so now we're going to have to do a little bit more work on this. We're going to have to kind of take a look at a couple of slopes and see what we think they are. So this is counting by 2's up to 10. So if I look at, for example, x is equal to 4, it looks like I have a pretty steep slope. So that's going to be kind of a high positive number, like maybe 5 or 6. So at x is equal to 4, I might have 5, so I should expect a value of like 4 or 5, which is this one. It's actually both of those. And at x is equal to negative 4, and I come down here, I still have a pretty steep slope for my tangent line there. And it's still positive. It's still positive. So x is equal to negative 4 should still be a positive 5 because the slope is still positive. So looking over here, negative 4 should still give me a positive 5, which it does over here. But over here it gives me a negative 5. That would be a negative slope. That would be as if this came up as a parabola. Then it would be a negative slope because it would be going from upper left to lower right. So now I can tell that this graph here is going to correspond with, which one? It's going to correspond with D, because I can see that at negative 4, my tangent line down here is going to, if you draw an imaginary line that goes through just this point right here on the graph, it's going to have a positive slope. So that means at negative 4, we're going to have a positive number here for our derivative slope, derivative graph. And so it's going to definitely be this one here. So using a process of elimination and a little bit of kind of characteristics of these graphs, we can find it. Now let's look at another example of one here. Similar question. Okay, now we have a parabola, just what we were talking about here. So once again, we only have one place at x equals 0, where we have a horizontal slope for our tangent line. So that means we should only have one place where the red curve touches the x-axis. So we can eliminate this one. We can eliminate this one. Oh, look at that. And we can eliminate this one. All right, all three of those, because this goes through 3 times, this goes through no times, the red curve goes through the x-axis no time, and this goes through the x-axis a bunch of times. And this goes through exactly once. So I already know it's this one, but let's see how that line works. X is equal to 4. We're going to have, once again, kind of a positive number there, because maybe 5 or something. At x is equal to negative 4, we're going to have a negative slope. It's going to go from upper left to lower right. So we're going to have a negative. And sure enough, if we go to x equals 4, we're going to get a number around 5. X equals negative 4, we're going to get a negative 5, somewhere around there. So it's definitely this one right here. And let's do it one more time, see if it gives us something different. All right. There we go. Here we go. All right. So using the same kind of logic before, how many places on this graph are we going to have a tangent line with a slope equal to 0? Well, we've got one here around x is equal to almost 4, x is equal to 0, and x is equal to maybe 3.9 or close to positive 4. So negative 4, positive 4, and 0. So that means we should have our red curve should go through those same x values on the x-axis. All right, so definitely not D, because that doesn't go through any x values on the x-axis. This goes through 1, 2, 3, 4, 5, 6. So it's definitely not that one, because this should only go through 3, because there's only 3 places with a tangent line with a slope of 0. This one only goes through 1, so we can eliminate that one. And this one goes through 1, 2, 3 at exactly the points that we want them to. And we could actually keep working if we wanted to, just to kind of show that it also follows the other characteristics. But if I'm looking at this, that's good enough for me. All right, so pick A, and I'm done. All right, if you have any questions, let me know, and I hope you have a great rest of your week. Thanks.